All right, as you've seen in some of the previous integration by parts problems, occasionally you're going to come across situations where you have to apply the formula for integration by parts multiple times, causing you to take an integration or an antiderivative multiple times. So here's one of the things we can do as a little bypass method. This is called a tabular method, and this will most often apply whenever you have x raised to some, you're doing an integral of x raised to some power times the sine of something, or x to some power times the cosine of something, or x to some power times e to some power. Whenever you have an integrand that looks like these are the situations where we can use the tabular method. Our method for finding the u value is still the same. So let's take a look at the first problem here. The integral of x squared times cosine of 3x. So the u value, applying Lie8, the algebra is going to come before the trig part. So the algebra is the x squared. So that is our u value. And then dv is going to be everything else. So dv is going to be cosine of 3x and then dx, but we're going to leave the dx part off. All right, so now the u's, what we're going to do is take the derivatives until we get down to 0. All right, so the derivative of x squared is 2x. The derivative of 2x is 2, and then the derivative of 2 is 0. All right, now with the dv column, we're going to take antiderivatives. So you can use u substitution here. The antiderivative of cosine 3x is going to be 1/3 sine of 3x, and the antiderivative of this is negative 1/9 cosine of 3x, and this antiderivative is negative 1/27 sine of 3x. All right, so once we've made this table, our next step is to look at the diagonals on this table. So the x squared matches up with the 1/3 sine 3x. The 2x matches up with the negative 1/9 cosine 3x. And the 2 matches up with the negative 1/27 sine 3x. Now, the first diagonal, we're going to put a plus on this diagonal. The next diagonal, we will put a minus. And then the next one is going to be plus. You're always going to alternate signs on your diagonals, however many it takes. And you're starting with the positive. All right, so what this is going to be then is positive 1 times x squared times 1/3 sine 3x. So our first term then is going to be 1/3 x squared sine 3x. That's our first term from right here. All right, so the next term is going to be negative 1 times 2x times negative 1/9 cosine 3x. Well, negative times negative will become positive. So we'll have positive 2/9 x cosine 3x. All right, so then our next term is going to be positive 1 times 2 times negative 1 over 27 sine 3x, which is going to give us minus 2 over 27 sine 3x, and our big fat plus c. And this is your antiderivative using the tabular method. Now, you could also check your work by taking the derivative of this. You'd have a product rule here, you'd have a product rule here. You can find the derivative, and the derivative of all this will come out to be x squared cosine 3x. All right, let's take a look at the next problem here. The u value, according to Lie 8, is going to be your x cubed. That's the algebra part. This is an exponential part. That's the last part, the e in Lie 8. So the u value is going to be x cubed, and then we take that all the way down to 0. So we're going to have 3x squared, 6x, 6, and then 0. All right, so the dv, that is going to be e to the negative 2x. The antiderivative of this, you would use u substitution to find that. Comes out to be negative 1/2 e to the negative 2x. The antiderivative of this comes out to be 1/4 e to the negative 2x. And then negative 1/8 e to the negative 2x, and then positive 1/16 e to the negative 2x. All right, so then we do our diagonals, and the first diagonal will be right here. Then this one, and this one. This time we have 4 diagonals. The first diagonal is positive, the next one is minus, then plus, and then minus. All right, so if we go ahead and write this out, we're going to be multiplying positive 1 times x cubed times this, which will give you negative 1/2 x cubed e to the negative 2x. All right, so then our next term is going to be negative 1 times 3x squared times 1/4 e to the negative 2x, which will give us minus 3/4 x squared e to the negative 2x. All right, so now we have positive 1 times 6x times this, which will give us negative 6/8, which reduces to 3/4 x e to the negative 2x. And then we have negative 1 times 6 times this. 6 times 1/16 will reduce to 3/8, so you're going to have minus 3/8 e to the negative 2x. And once again, plus our constant c.